Yeah. Okay, now we have to compare the two regulations, right? So let me remind you the story. I do a new picture. Oh, not this pen. This one. Okay, so this is marginal damage. So this is the expected marginal cost. Okay, now if you set an emission cap, you pick this one. If you set a tax rate, you equalize tax to the marginal damage at the ex ante efficient emission level. So this will be the tax rate. Another way to say that is you set a tax which equalizes the marginal damage to the expected abatement cost. Okay? Okay, so this is a regulation you set as a regulator. But now it turns out that marginal abatement is, let's say, lower than expected. So this is what is in reality a law. If there is a standard, the firm is sticking on the standard on the cap, emitting the cap. If there is a tax, the firm reacts by equalizing the tax to the marginal abatement cost, and therefore that will be the level of emission for the low-cost firm with a tax rate. So what is chosen by the firm with a tax. Now you have to compare the two. You know what is the first best? Given that the costs are low, what you should have is level of emission, where these two lines cross, marginal damage equal to marginal abatement. That should be what you should have chosen as a regulator, or implement as a regulator. So you are never in the first best, but what is the best? Is it the best to? Is it the better, or what is the best regulation? You have to compare the loss of welfare. How to represent the loss of welfare in this picture? So remember the welfare. Yeah, sometime somewhere. The welfare is captured by the overall cost of emission. Okay. It is minimized here. And as you move, it increases. And for how much? Now consider the case of the cap. What will be the loss of welfare? The triangle is here. Why? Okay, suppose you move from the first best by emitting less. Then the problem is that the marginal damage of this you emit less, so you abate 1 unit. The marginal benefit of this abatement is the marginal damage is higher than the cost. So then you are losing this. This is what you are losing for the first unit. And every time you emit, you abate, the benefit, which is a marginal damage, is the benefit is lower than the cost. So the marginal damage is higher than the marginal abatement. So this is what you are losing by emitting less. Sorry, I was mixed up. You are emitting more than the first best. Okay, that's more. So the problem that the marginal damage of this extra emission is higher than the marginal cost. So you should emit less. That's it. So, and then the difference between the marginal damage and the marginal cost is the social loss due to the new extra emission level, new unit of emission. So you emit one more unit, the loss will be the difference between the marginal damage and marginal cost for this one more unit of emission. And you can also apply this principle for all extra unit. So this is for the first, for the second, for the third, and so on. And at the end, you get the area of this triangle. So this surface represents the loss of welfare, well, if you set an emission cap compared to the first best. What about the tax? Same story, but on the other side. Now the problem is that since the tax is based on higher expected cost, you provide too much incentive to reduce emission, to abate. Okay, at the point that the marginal cost is higher than the marginal damage. Okay, so for each unit here, there's the loss of welfare, which is the difference between the marginal cost, which is higher than the marginal damage. It's more costly for society than it's worth in terms of benefit. So this is what the welfare you lose for the first unit, for the second, for the third, for the fourth, and so on. So in total, this is a total loss of welfare with a tax. So then, so you have to compare this area to this area if the costs are low. But as a regulator, ex ante, you don't know if the costs are low or high. So this is how you could compare the two regulations from the ex post point of view. Okay? Once you know that the costs are low, then you can compare how much you are away from the first best and the loss of welfare by evaluating those areas. But from an ex ante point of view, you have to consider there both cases, the case of low cost and high cost. So then you have to consider that with probability 1 minus 5, new costs are high, and then you have the same story with this high cost. That will be the emission of high cost with a tax rate. That will be the emission with the standard, and this is the first best. And you have the same triangles. Okay? Now, this is what you should do, but the tax is based on expected costs that are lower than the real cost. Okay? There is less abatement, more emissions, and the loss of welfare is this triangle. This is with the tax, and with the cap on emission, this is a cap, and the loss of welfare is this triangle. So the ex ante loss of welfare in expectation is the average among the two loss of welfare. So you take the average of this loss of welfare and this loss of welfare with the tax rate. And with the standard, you take the average of this one and this one. And you compare the two. Now, in my picture, what is the best instrument? Oh, more or less. Yeah, it seems that this is bigger than this, no? Yeah. I will say tax is better, but you know, I have other picture in which this is clear. So you compare these two areas graphically, and what do you get? So this is this story. This is a welfare loss with a cap on emission. This is a welfare loss with a tax. So here you compare the two, take the expectation, and well, this is an example in which the tax dominates. Okay, because you can see that this is a welfare loss with a tax, low cost, welfare loss with a tax, high cost, and this is a welfare loss with a standard. Exactly. This can see the marginal damage is quite flat. Now, marginal damage is quite deep. And then the reverse. Okay? This is the loss of welfare of the cap, and with this was the tax. Okay? You can do the same by, instead of changing the slope of the marginal damage, you change the slope of the marginal cost. And this is what you get. And then the tax is better. Okay? This is a loss of welfare of the tax, loss of welfare with cap on emissions, and the reverse. Okay. So what can we conclude from that? So this is the main result. Emission standards or emission cap are preferred if marginal damages are more steeply sloped than marginal abatement costs. And emission fees are preferred otherwise. So you compare the slope of the marginal damage and marginal cost, and it turns out that the marginal damage have a higher slope than the marginal cost. Then you prefer an emission cap. If it's a reverse, it's a tax. If you have a flat marginal damage and a very deeply sloped marginal cost, you should tax. Actually, if you have a completely flat marginal damage, then you can even implement the first best with a tax. So the choice between, again, you are always wrong in general, except when the marginal damage is exactly flat. But how much you are wrong depends on the slope of these two curves, of those curves. And of course, it's not easy. So as a regulator, you may say, okay, if you advise a regulator, you will say, as an economy, you will say that. You will say, well, it depends on the slope of marginal damage, marginal cost. But in reality, it's not so easy to compute those slopes. So what can you do? Well, you can have an idea about that, about those slopes. So there are different ways to interpret those slopes. So these are some examples. For instance, you can have marginal damage that are like this, for instance. You have something like this. So this is an example. For instance, it could be that the biosystem can cope with a little bit of pollution, but there is some threshold. So in terms of emission, and the marginal damage is quite low, and then this threshold is infinite because it's a disaster. Everything, like think about the lake, some fishes, and they die above some level of pollution. Because there is very deep slope in this part. So if you are focused in this part, you should cap emissions. If you are in this part, you should get a tax, for instance, on pesticide, or fertilizer, for instance. So in the case of threshold, you have irreversible damage, for instance. You lose some species, for instance, some fishes. But on the other hand, if you think about climate change, you may think that the marginal damage is quite flat because your impact on the climate change is quite low at the world level. So marginal damage of 1 more ton of CO2 is flat. Okay? It does not change a lot, for each ton of CO2, of course. But yeah, but the question is marginal damage. What happens if you have one more unit of emission? How it changes the damages? So what you have in mind is this, that you regulate when you are around this. But it could be that you are here, and then if you regulate here, it's quite flat, But if you are here, you should have an emission. And you have the same story with marginal cost. It could be that marginal costs are quite flat, or it could be like, one example are capacity, production capacity, for instance. When you have production with some fixed capacity, the short-run marginal costs are quite low up to the capacity. Think about, for instance, electricity production with a thermal power plant or nuclear power plant. So there's a capacity of production, okay, and the cost is as follows. You need some fuel, and then it's infinite because you use the maximal capacity. So in this part, marginal costs are infinite. So the slope is very high. In this part, it's flat. Okay. So if you are regulated on this part, it's very costly to do a mistake. So you should tax. If it's in part, you should quota, right?
No, you shouldn't.
You should get a standard. I already. Emission fees, I prefer. No, you should tax. No? If the slope of the marginal costs are very high, you should tax. This is what the theorem says. Okay, so from a practical perspective, as an economist, what you can say, well, we could evaluate marginal cost and marginal damage compare, but you can say if you are economic advisor of one regulator that, well, in this case, it's reasonable to think that, marginal costs are deeply sloped or not, or marginal damage are more deeply sloped, okay? So this is a guideline on how to choose among the two regulations. Okay. What about the proof? The proof is quite easy. I won't go into the proof. Sorry for that. I'm sure that you will appreciate. But you can find a nice proof in the book from Baumol and Oates. So the proof is with linear marginal cost and marginal benefit, and it's work with abatement instead of emission, but it's just a change of variable. So you can have a look on this book if you want to prove. Basically, it's quite technical, and okay, another thing is, of course, if you want to compare the slope of marginal damage and marginal cost, you need something which is linear. Otherwise, the slope is changing with emission or abatement. So there are two interpretations of that. So what Weizmann tells you in his paper is that the quadratic damage and cost, or linear marginal damage and linear marginal cost, or just approximation of local approximation of real marginal damage or real marginal cost. Okay? So you can think this is an approximation of what is like in all models. Okay. Now, since Weizmann, there's been a growing literature on the choice of between tax and emission standard, or price versus quantities. So these are a couple of directions that this literature has gone. One was in terms of complexifying the regulation. So here we took only two very simple regulations: tax, emission, or set a cap. But in reality, you can have more complex regulation. You can have a tax for the first unit of emission up to a cap. So firms are allowed to emit up to some cap, but there are taxes for the first unit. There's a cap, and but then also here we have assumed that there is a no enforcement problem. The cap is binding, and the firm is not allowed to exceed the cap. But in reality, there can be some enforcement, and so you have to design a penalty if the firm exceeds the cap. Now, if you have a more complex regulation, you can try to mimic more the damage function. And this is what you have shown in those papers. Some paper what you have shown that if you have some complex regulation, you can have something like this. You have a tax, and then a cap, and then a penalty if you exceed the cap, something like that. So then you have some it's equivalent to have some kind of tax schedule. This is the cap here, for instance. And then you kind of try to mimic the damage function, then of course you improve compared to only a tax per unit of emission or only a cap. So of course you can improve by complexifying the regulation and try to, again, the idea is to try to make the firm internalize the social cost of its emission with penalties, taxes, allowances, or right to emit that matches the damage for society. Weizmann also has written also an extension in which he considers a stock pollutant. So it's an extension to several periods, and the pollution, the level of pollution accumulates across time. So then he showed that then the problem is more complex and the results are different. And recently with Jessica, we wrote a paper in which we generalized this result in a model with more than one pollutant. So it's a model with two pollutants, and those two pollutants are interacting to the cost function of the firm. So think about CO2 emissions and SO2 or NOx, like coal thermal plants are emitting different air pollutants, and including those two, and they have different impacts on the environment. One is climate change, the other one is about acidification and acidification of forest, lakes, or health problems. So there are potential different damages. And then one big issue is how those two emissions, two pollutants, are interacting to the cost function, as I said, but also into the damage function. And in the cost function, that can be complement or substitute, in the sense that it could be in some case that the more you abate on one pollutant, the more you reduce CO2 emission, the cheaper is to abate on the other pollutant, SO2 emission. Or it could be the reverse. It's becoming more expensive than to abate for the other one. So you have kind of economic of scope or diseconomic of scopes in the two pollutants. And then what is new here compared to Weizmann is that this economic of scope or diseconomic of scope parameter affect the choice of the two among the two regulations the same way than the slope of the marginal cost function. So we have a condition which says that if the slope of the marginal cost function plus this parameter exceeds the slope of the marginal damage, you should go for tax, and the reverse should go for emission standard. Okay, this is one result, and we have another result which says that it could be sometimes efficient to have one pollutant which is regulated by an emission cap, and the other one regulated by a tax. Okay, so sometimes even if the two pollutants are symmetric in terms of cost and damage, sometimes it's better to have two different regulations for the two pollutants. Okay, so I'm done with the Weizmann result, and I will start the second part of the course, which is on contract-based regulations. Now the story is different. Instead of imposing one regulation, one tax, you let the firm choose among different types of regulations. Here are a couple of examples. In all these type of regulation, you have different level of abatement or emissions and different transfer schemes, like different tax rate, different subsidies. And here I have a couple of examples. So in this lecture, I will refer to one empirical paper by Mason and Plantinga, which deals with the purchase of land for carbon sequestration. Okay, you know one popular way to mitigate your or offset your carbon footprint can be to purchase land to sequester carbon by planting trees. Now the problem is you want to purchase this land at the lowest cost, but you don't observe how much the landowner is willing to be paid to convert this, let's say, agricultural land to a forest. This is private information. So then you want to design a scheme such that you purchase this land at the lowest price. So the scheme is as follows. You pay the farmer a share of its land, which is a subsidy which is proportional to the share of its land. So there is different shares and different payments. And this is a menu of regulation or contract I am talking about. And there is the same story about the biodiversity conservation. You want to convert some agricultural land into forest to preserve some species like, I don't know, the bear, some animals. And also you need to portion land, and you don't know, I mean, there's a private information about the value of the land. Another example is the agro-environmental schemes. So these are some subsidies that are proposed by the agricultural policy from the European Union that aim to convert traditional farming into organic farming, let's say, or to compensate farmers for reducing their use of pesticide or their pollution. So it's voluntary based, so farmers are not obliged to comply with those schemes, and they get paid for that. And they can choose among different schemes. So there are some schemes in which they just decide to reduce the use of pesticide fertilizer by a certain amount, and they get some subsidy for that. And there are other schemes that are more stringent. For instance, they may choose to move to organic farming. That means using no pesticide and only natural fertilizer, or not some pesticide maybe, but not the standard one. So this is more abatement. That means in our model more abatement, but also a higher payment. So the scheme is with different abatement levels and different level of subsidies, depending, and let the firm decide on which abatement, which program the firm would choose. So the question is how to design those schemes if you don't observe the abatement cost of the firm. So for the farmer, don't observe what is the cost of the farmer to implement those abatement levels. So this also can apply to what are called voluntary agreements to some extent. Although in voluntary agreements, you don't always have subsidies. So what is a voluntary agreement in the literature in environmental regulation? It's an agreement within an industry with the regulator on some abatement or some procedure to reduce pollution. So for instance, there is an agreement that has been launched in the US with the Environmental Protection Agency by some big polluting industries to reduce their emission of several pollutants by 30% and 50% depending on the pollution. So it's called the 3350 agreement. So they didn't get paid for that, but they get some compensation in terms of dealing with the regulator, for instance, or avoiding future pollution, or future regulation. And in those agreements, again, those agreements are signed by the industry, but firms, part of those industries, are free to enlist or not so to implement or not those procedures, for instance. So it's voluntary, it's not mandatory. So, for instance, let's see how Mason and Plantinga have modeled this kind of problem. It's very close to our model, indeed. So it considers a decision which is a share of land that is converted into forest. So X is a share of land. So you can think like a little bit like a abatement strategy in the model. Then there's the cost and the benefit. The benefit is from the regulator. You reduce, you sequestrate carbon, you reduce emissions. Even you, and the cost is for the firm, which is a farmer, and it depends of parameter theta, which is private information, like in our model. And theta is a share of costless forest. It is the share of forest, which is the share of land which can be converted or which is in forest at no cost. So in the model here, it was like the laissez-faire level of emission somehow. So I mean, the idea is that the farmer has some share of land in which he doesn't want to cultivate, and therefore it can preserve this share of land at no cost. Whereas here the policy is to pay him or her for converting those land into forest, or to having a forest on this land share. So you pay for nothing basically. So that's a problem. And so then the cost of preserving forest or planting trees depend on the difference between the share implemented by this contract and what is free for the regulator. So free for the farmer in a convex way. So it's very similar to the cost function we had so far. Now, what is the contract-based regulation? The contract-based regulation specifies different share and different subsidies. For each share, if you decide to preserve 50% of your forest, you get a certain subsidy. For 20%, you get another subsidy. So it's a menu of share and transfer. Another way to say that is the subsidy will depend on the share. Why does it depend on theta? Because for each share of subsidy corresponds to one specific farmer. So you will design the scheme, the abatement and the transfer contingent on the type of farmer. And each vector of abatement and transfer is designed for a specific farmer. So it's one way to see that it's a subsidy contingent on abatement. Okay. Now, how to model this problem? So what we will do, we will have a, yes? Well, basically, if you go in the countryside, there are many places in which it's very costly to cultivate because the land is not well shaped, and so there are wood naturally left by the farmer because there are plenty of stones or marshes, and this is the idea. Or maybe it's far away from water, for instance. So I say costless, but it could be very high cost, or Yeah. I mean, when those policies have been launched, some people say that, or like the red mechanism, for instance, the red mechanism to preserve, so you pay farmers to preserve their forest. Some people start to say, well, we pay something for, for nothing. I mean, they would prefer anywhere those forests because they don't want to exploit those forests. I don't know, they are busy with another one. I mean, depend of course of the context, but you can imagine in many cases that the cost is lower, because in forests are not exploited. I mean, empirical evidence that many places forests are not exploited. But if you want more justification for this assumption, just have a look on the paper. I'm sure that he has some. Okay, so how to model this problem? First, it's in mechanism or in information economics, it's called an adverse selection problem. So there are different types of asymmetric information. Maybe you can cite a couple of ones. So one is adverse selection. What's the other type of asymmetric information?
Moral hazard.
Moral hazard. So what's the difference between adverse selection and moral hazard? Yeah. So it's ex ante asymmetric information before the contract or is signed. Moral hazard is after. Another difference is here. It's the type of cost is not chosen by the firm. So the firm is borne by a high cost or low cost, whereas for moral hazard, it's a choice of the firm to the worker to work or not, or to a driver to be prudent or not. So you have good driver and bad driver. That's an adverse selection problem. But the driver can be prudent or not, and that's a moral hazard problem. When you are talking about observation emissions, that's another moral hazard problem. So it could be that firms, you cannot observe emissions, but you ask emission to firms, and firms can lie, pretend they are emitting less than, and that's a prime moral hazard. So it's a prime adverse selection. Here, what we will do, we will rely on the revelation principle. Okay, so there are potentially many mechanisms that we could consider, and there is a fundamental result in mechanism design, which is the revelation principle, which tells you that without loss of generality, you can rely on what is called the direct revelation mechanism. So you can find out the best mechanism by a direct revelation game. Okay, and the game is as follows. You set a mechanism, like a menu of contract. You let the firm decide which contract the firm chooses. And then the firm sends a message about its true cost, which is one way to select among the menu of contract. So it's a direct mechanism in the sense that the firm sends information about its true cost, the theta parameter, for instance. And then it's a revelation mechanism because in equilibrium, the message should be truthful. That is, the firm should send the real cost, the real information. So the revelation principle tells you that you can not do better in terms of welfare than with the direct revelation mechanism. So you can focus on the direct revelation mechanism, and that gives you the best mechanism you can implement in this framework. Of course, in practice, that does not mean that the game plays the same way. That doesn't mean that in practice you propose contract and you ask about the type and so on. You can have different ways to implement this mechanism. But here everything can be as if you do this way. You consider this kind of game. Again, the game is that you design a menu of contract, firm accepts or rejects, then the firm sends a message about its true type, and then it must be that in the Bayesian-Nash subgame perfect equilibrium, the firm tells the truth. And what is a contract? Here, in our framework, it will be a menu of emission and transfers. So a menu of abatement, emission is related to abatement, and some subsidy for some level of abatement. So the firm is free to sign the contract, and by signing the contract, the firm pick one of the two. And it should be that all firm of type L, so all low-cost firm pick this one, and all high-cost firm pick this one. This is one way to reveal their tip. Okay. So that's what we are going to analyze. And the objective, as before, is to maximize total welfare, and here is as before to minimize the social cost of the expected social cost of pollution. But now we have two constraints. One constraint is that the firm participates. So all firms will pick a contract. And the second one is that it's incentive compatible in the sense that they all tell the truth. So are you familiar with this kind of... okay. So it's application of mechanism design to environmental regulation. Okay. So the same model, just so you know. The difference here that there is some transfer. So the regulator does not consider the abatement cost directly into its social welfare function, but through the transfer. Okay, the idea that you are going to compensate the firm for the abatement cost, and you want to minimize this compensation. That's why the regulator wants to minimize the damage due to emission plus the transfer to the firm. And the transfer should cover at least the cost, abatement cost, to be sure that the firm is actually abating. The firm is actually participating, accepting the contract. So it's really voluntary based. If the regulator will know about the theta, he will implement the first best, the same level of emission we've seen before, equalizing marginal damage to marginal cost, and pay only just the cost of abatement, because transferring money, subsidizing is costly. So there will be first rate emission and no rent to the firm. The firm will just be reimbursed through the abatement cost. What is the problem with this regulation or under asymmetric information? Because the problem that it does not induce truthful revelation of information. So if you let the firm say, choosing among the two levels of abatement, so you can decide to abate the first best to the low cost or the high cost, and in each case, you get reimbursed for your abatement cost. This is a kind of full information mechanism, but suppose there is asymmetric information. Suppose that then what will happen? What will happen that all firms will pretend to be of high cost. Especially the low-cost firm, the more efficient firm, will pretend to have high cost. Why? Because by pretending to be of high cost, the firm will have to emit the high cost level, which is higher. It will be reimbursed based on high cost. So then, this will be the net gain of the pretending to be high cost. The firm will have to emit the high cost, will be paid the high cost, and that will be and the abatement cost will be the cost of emitting the high cost level, but with the low cost function. And if you reimburse based on high cost, this is a benefit that the firm will get, which is positive. So then you will end up with all firms pretending to be high cost, and if the firm turns to be low cost, the firm will over-emit compared to what is first bet, and you will have to pay more than the abatement cost. So the point here is you can improve on compared to that. So if you make the parallel with the carbon sequestration story with forestry by Mason and Plantinga, this corresponds to the uniform subsidy. So you pay farmer for each hectare converted to forest, whatever is the share of forestry in their land. It's a subsidy regardless of the share preserved in the land. Okay, very simple. This is what will happen. Yeah, so you have something which is inefficient in terms of incentive, and also you're going to pay for some land which will be preserved anyway. So the point of their paper is to see maybe we can improve by some more complex scheme, take into account the incentive of people. And this is what we are going to do after the break.